Deadlock detection and recovery. What is a deadlock? Deadlock can be defined as a situation in which two programs sharing the same resource are effectively preventing each other from accessing the resource, resulting in both programs to malfunction. All these four must happen simultaneously for a deadlock to occur. Mutual exclusion. One or more than one resource must be held by a process in a non-shareable exclusive mode. Hold and wait. A process holds a resource while waiting for another resource. No preemption. There is only voluntary release of a resource. Nobody else can make a process give up a resource. Circular wait. Process A waits for process B waits for process C waits for process A. Deadlock detection and recovery algorithm. This algorithm allows deadlock to occur, then detect and recover the state. Let work and finish be vectors of length m and n, respectively initialize. Find an index I such that both A finish is equals to false and B request is greater than or equal to work. If finish is equals to true, go back to step 2 and repeat the process. If no such I exist, go to step 4 where the system is now in a deadlock state. A simple way to detect a state of deadlock is through a graph called wait for graph. To detect deadlocks, the system needs to maintain the wait for graph and periodically to invoke an algorithm that searches for a cycle in the graph. Consider the following wait for graph. Transaction T25 is waiting for transactions T26 and T27. Transactions T27 is waiting for transaction T26. Transaction T26 is waiting for transaction T28. So since there are no cycle, there is no deadlock state. Suppose that transaction T28 is requesting a data item held by T27. Then T28 is connected to T27. This time the graph contains a cycle. This means that transactions T26, T27 and T28 are all deadlocked. Once a deadlock is detected, you will have to break the deadlock. It can be done through different ways, including aborting one or more processes to break the circular wait condition causing the deadlock, preempting resources from one or more processes which are deadlocked, and by also informing the system operator and allow them to take manual intervention. In the previous wait for graph, transactions T26, T28 and T27 are deadlocked. In order to remove deadlock, one of the transaction out of these three transactions must be rolled back. When a deadlock is detected, the choice of which transaction to abort can be made using the following criteria: the transaction which has the fewest locks, the transaction that has done the least work, the transaction that is farthest from completion. Once we have decided that a particular transaction must be rolled back, we must determine how far this transaction should be rolled back. The simplest solution is a total rollback. Abort the transaction and then restart it. However, it is more effective to roll back the transaction only as far as necessary to break the deadlock. But this method requires the system to maintain additional information about the state of all the running system.